Hello, I'm Nadzirah Haziqah Binti Irwansyah.
My name is Daud Naqib by Yusoff.
Hi, greetings. My name is Mohamad Dzarif bin Malek.
Hello, my name is Naomi, Karmilla, and I'm from Group 3J.
Let's begin with a simple process flow diagram of the production of acetaldehyde. It consists of reactors, separation units, storage tanks, and other equipment. However, our main focus would only be the stripper column. The stripper column is the last separation process involved in this production. It is a physical separation process where components are removed from a liquid stream by a vapor stream. It is where 99% purity of acetaldehyde is obtained at 110 degrees Celsius 1 atm. In order to ensure the safety of plant, it is very important to apply the knowledge of process safety and loss prevention to avoid any unwanted occurrences such as fire, explosion, and release of harmful substances. The objectives of this video are to identify any hazards present in the unit, perform Haziqah study, and recommend any improvement regarding the safety of the plant. Let's dive into hazard identification first. The first hazard is temperature hazard. The stripper column is operated at 110 degrees Celsius. It is dangerous because this high temperature can lead to loss of structural strength, heat stress, burning of workers, if any accident occurs such as leakage and spillage in the column. The second hazard is chemical hazard. Most of the components in the stripper unit are flammable, which means they are liable to self-ignite when exposed to air or water. This is mostly due to their low flash point. The fire is followed by release of harmful gases which may damage human health as they are either toxic, carcinogenic, or mutagenic. Irritation is also present, which has immediate effect by irritating the skin, eye, and respiratory tract. It also has corrosive hazard, which can cause skin corrosion, burns eyes, and damage contact. Since we are handling with gases that are under pressure, compressed gas hazard is available too. There are 4 chemicals present in the column. The first one is acetaldehyde, which has flammable, irritant, and health hazards. The second one is chloromethane, which has hazard symbols of flammable, irritant, compressed gas, and health hazards. The third one is acetic acid, which is flammable and corrosive. Lastly, chloroethane, which has flammable, compressed gas, and health hazards. Now let's focus on the Haziqah study that has been performed on the stripping unit. Haziqah is a technique used to identify potential hazard and operating problems. The study node remains constant throughout this video as our main focus is only on the stripping column. However, we have 4 different process parameters: flow, temperature, pressure, and level. The first process parameter is flow. The guide words are divided into no, high, low, reverse, and as well as. When there is no flow present, the consequences are column dry out, possible dangerous concentration, and no operation. It can be caused by the use of control valve fails closed, hence it is recommended to use a control valve fail open instead. Blockage of pipes and tubes may also occur, so installing filter, flow meter, and low flow alarm can be done. Another possible cause is failure of controller that opens the valve, which can be resolved by placing the controller on instrumentation list. If there is a high flow into the column, flooding and changes in product quality are the consequences to it. One of the possible causes is the use of control valve fails open. Action that can be taken based on that are instructing operators, update procedures, and install flow indicator. High flow might also be caused by failure of controller that closes the valve, which can be resolved by placing controller on instrumentation list. When there is low flow into the column, the consequences are similar to no flow, which are column dry out and changes in product quality. This may be due to partially plugged pipes and tubes. Hence, filter, flow meter, and low flow alarm can be installed. Failure to respond of the control valve is also possible, so the valve can be placed on critical instrumentation list. As for reverse flow, it may be caused by pressure build-up which lead to backflow. Therefore, the check valve needs to be installed to prevent that from happening. If the stripping column has flow as well as other components, it is due to contaminated solvent which can compromise further process. Actions required are to follow proper storage and handling procedures, employ quality control measures, and use certified grade material. The second process parameter is temperature. When the stripping column is set to a different temperature, whether it is higher or lower than the usual operating temperature, the consequences to the unit are similar, which are inefficiency of separation, changes in product quality, phase effect, product loss, and pressure changes. High temperature can be caused by an increase in steam flowing into the unit. It can be resolved by giving more attention to heat input and output control. When there is high steam pressure, operator can be instructed on procedure to resolve the issue. Another possible cause is failure of condenser, which can be resolved by installing temperature indicator and high temperature alarm. As for low temperature, the causes are opposites to those in high temperature, but the actions required remain the same. The third process parameter is pressure. The consequences of high or low pressure are similar, which are inefficiency of separation and product loss. The difference is that high pressure can also lead to rupture of column. The possible causes of high pressure are high vapor pressure and failure of pressure indicator controller. Actions required for such causes are installing high pressure alarm and pressure relief valve respectively. As for low pressure in the unit, it might be due to leakage of vapor line, which can be resolved by installing a pressure indicator. The last process parameter is level. When the level in the unit is higher than normal, it might be caused by blockage of pipes and tubes in the output, which can lead to overpressure. Therefore, it is recommended to install filter, flow meter, and high flow alarm. As for low level, the consequences from blockage of pipes and tubes output and leakage in column are column dry out and changes in product quality. Similar to when the level is high, the action that can be done when level is low are installing filter, flow meter, and low flow alarm. Now let's move on to our last objective, which is recommendation. The first recommendation is to install indicators to help monitor each parameter. This way, the person in charge knows that the parameters are in line with what have been set. Alarms can also be installed to notify the person in charge when parameter variation occurs. In order to ease the job of the person in charge, installing controllers are also recommended so the control system can help to ensure the parameters remain at a steady state. In case of any unwanted accidents, emergency shut-off valves can automatically shut down the whole operation without further compromising the process. Last but not least, it is very important to properly plan and design the process plan by ensuring equipment is suitable for the process. Many hazards can be prevented with proper planning. In conclusion, process safety is very important to eliminate loss and harm resulting from fires, explosions, and hazardous material releases at process facilities. In order to do that, process hazards need to be identified, followed by controlling the hazards and countering them with effective safeguards.